This video is about the magnetic force on a moving charge. When a charge moves through a magnetic field, it experiences a magnetic force. The direction of the force is not what you would expect. As an example, say we have a uniform magnetic field that points down the screen, and I've labeled it B external because it's made by some external source, like some permanent magnets that I'm not showing. And now I have a charge, say a positive charge, and let's say it's moving to the left with some velocity v. Then because this charge is moving through a magnetic field, it experiences a magnetic force. In this particular example, the direction of the magnetic force is coming out of the page. So this is typical in these magnetic force problems that we have to deal in 3 dimensions. So we need a convenient way to show vector directions that point into or out of the page. So here are some symbols that we can use to represent that. So this symbol represents a vector pointing out of the page. And sometimes you might see it as just a dot. And then we have this symbol, and that represents a vector that points into the page. Or you might just see it as an X. So you can think of the first symbol as the tip of an arrow that's pointing toward you, so the vector's coming out. And then think of the second one as an arrow going away from you, so you're looking at the tail of the vector as it goes away from you. And so using these symbols on the example above, the direction of the force could be written this way. So now, how do we determine the magnitude and direction of the magnetic force? Let's start with the magnitude. By experimentation, the magnitude of the magnetic force depends on the speed of the charge. The greater the speed of the charge, the greater the force. And if the speed is 0, the force is 0. And also the magnitude of the magnetic force depends on the angle between the direction of the magnetic field and the velocity of the charge. The force is greatest when the angle is 90 degrees between those two vectors. And the force is 0 when the angle is 0 degrees or 180 degrees. In other words, if they're pointing in the same direction or opposite directions. And so these facts are expressed in the Lorentz force equation that I'll write down in just a minute that gives us the magnitude of the magnetic force. And then one more fact we get from experimentation is that the direction of the magnetic force is always perpendicular to the magnetic field and to the velocity or the direction that the charge is moving. And this is a key fact we'll make use of in just a moment when we discuss how to determine the direction of the magnetic force. So now back to the magnitude of the magnetic force. Again, we get that with the Lorentz force equation. The Lorentz force equation provides the magnitude of the magnetic force on a charge that's moving through an external magnetic field. So here's the equation, where Q is the charge of the object charge, and V is the speed of the object charge, and B is the external magnetic field. And I keep saying external because it's made by other charges, not the object charge. And then the angle theta is the angle between V and B, between the direction of the moving charge and the direction of the magnetic field. As an example of how the angle affects the magnitude of the force, let me show you this picture. So here's an external magnetic field, and so that field's made by magnets or moving charges that are not necessarily shown, but as an example, say we had a north pole of a magnet to the left, or we had a south pole on the right side, or perhaps we have both, but either way, this external magnetic field is produced. And now we put a charge in this field. Now if this charge is not moving, it will not experience a magnetic force. If it's moving up like this, then it experiences a maximum force because V and B are 90 degrees to each other. Or if it's moving down, it also experiences this maximum force. But if it's moving to the left or the right, then the angle is 0 or 180 degrees, and then it does not experience a magnetic force. And if the angle is somewhere in between, then the magnitude of the force is somewhere in between 0 and the max. So for any of these directions, let's say the magnetic force is a medium value. Now let's talk about the direction of the magnetic force. It's a little bit tricky, and it's very much a visual thing. So in this video, I'll just give you the basic rules, and then in the next video, you can actually see me apply the rules. So here are the rules. The first thing you want to do is identify the plane made by the two vectors v and b. The reason why you want to do this is because the magnetic force, as it turns out, will be perpendicular to this plane. So by taking this step, we narrow down the direction to two possibilities, into the plane or out of the plane. And then the next step will determine which of these two directions is the correct direction for the force. So we'll determine which perpendicular direction the magnetic force is by using what's called the right-hand rule. And we'll have a few different right-hand rules in this course. So we're going to call this right-hand rule number 1, which is used to find the direction of the magnetic force. So here's a description of right-hand rule number 1. And this is really the part that's difficult to express in words or writing here. So I'll just state the basic procedure, and then in the next video, you can see me demonstrate the right-hand rule and apply it to some problems. The first step is to straighten your right hand, and by that I mean the fingers on your hand, the palm of your hand, the wrist, to straighten them all out so they all point the same way. And then point your fingers in the direction of V, the direction the charge is moving. And then the second step is to rotate your hand, and really your whole forearm, until you can then bend your fingers toward the direction of the magnetic field. And the rest of your hand should continue to point toward the direction of V, so don't let the rest of your hand point in another direction. All you're doing is rotating your hand. And then finally, extend the thumb of your right hand, and it will point in the direction of the magnetic force for a positive charge. If it's a negative charge, then the magnetic force direction will be opposite the direction of your thumb. Okay, so that's the end of this video. Be sure to see the second one where I demonstrate this procedure and determine the direction of the magnetic force in some examples. And there are also 2 worked out examples that are posted on Moodle, and you should view those as well.